Okay, we are going to tackle 7-5, adding and subtracting fractions. So sometimes you might be adding, sometimes you might be subtracting. Tyler and Dean ordered pizza. Tyler ate half of the pizza and Dean ate a third of the pizza. How much of the pizza was eaten and how much is left? So we've got a couple things to do. You can use number sense to help you solve the problem and show your work. So how could we solve this one? So Tyler and Dean ordered pizza. Tyler ate half the pizza and Dean ate a third. How much was eaten and how much was left? So one way you can do it is you can draw a picture and you can actually, let me get rid of that. You can actually draw a picture. So you wind up turning this into sixes. So you can see that. And why did I pick 6, halves and thirds? I know that would be a common multiple, would be 6. So then you could see by drawing the picture how much is left. 1/6 of the pizza is left. You can also figure out how much they ate, 1/2 plus 1/3 if you do it math. And remember our 3 things. Are the denominators the same? No. Does one go into the other? No. So now I'm going to have to rename both. So I'm going to find a common multiple of 2 and 6. I can actually multiply, or 2 and 3. I can multiply 2 times 3 and get 6. And then I can just rename my fractions. 3/6 and 1/6. And all together they ate 5 6s. An entire pizza is 6 slices. I picked 6 6s because I have a 6 in that denominator, and I want to be able to not have to do anything. So that's why I picked 6 6s. And so I have 1/6 left over. Okay. 2 different ways you could solve. All right. How can adding and subtracting fractions help you solve problems? Kayla had 9/10 of a gallon of paint. She painted the ceilings in her bedroom and bathroom. How much paint does she have left after painting 2 ceilings? So she has 9/10 of a gallon of paint. So what did she start out with? If you move down, you can see step 1, find out how much she used, first of all. And we're going to add our fractions. And then we're going to subtract from what she started with, which was 9/10. So she used 2/3 and 1/5. So when we added them together, we got 13/15. So we took that value and we subtracted from what she started with, which was 9/10. Okay. And we can always estimate to check our work. It's a really good idea. Let's do some of the guided practice. In the example on page 396, how much more paint did Kayla use to paint the bedroom ceiling than the bathroom ceiling? So going back to the problem, she used 2/3 of a gallon for the bedroom and so hard for me to see. These are so little. And 1/5. There we go. For the bathroom. So we're going to subtract. So we need to go through our 3 strategies. Are they the same? No. Does one go into another? Does one denominator evenly go into another? No. So I'm going to have to rename both fractions. I can just use the strategy because those are both prime numbers. They're very small numbers. So I know if I multiply 3 times 5, I will get a common multiple. And to get from a 5 to a 15, I had to multiply by 3. So 1/5 is renamed to 3/15. And 2/3 will be renamed to 10/15. And I subtract them. 10 minus 3 is 7. And I just bring my denominator over. So there we go. So we have 7/15. Now, nobody would ever in any universe be solving math problems like this with fractions and paint, but whatever. Kevin estimated the difference of 9/10 minus 4/8 to be 0. Is this estimate reasonable? Explain. I would say no, because if you go back to the first lesson, 9/10 is very close to the number 1, and 4/8 is very close to 1/2. So if you said 1 minus 1/2, your answer would be 1/2, not 0. So I'd say no, his answer is not reasonable. And for our little problem solving for the sum and difference, I'm going to write the problems. Remember, you need to be writing in a notebook. You can't, and if you don't have enough room to write in your math book. So write the problems, stack them up, just like they're stacked up here. Like these little guys, 5 and 6, we'll stack them up too. And go through your 3 strategies. Number 1, are the denominators the same? No. Number 2, does one denominator go into another evenly? No. Number 3, I need to rename. So if you use my strategy, Mrs. Brennan's favorite strategy, you find the bigger number and you start skip counting by it. 15, we already said 6 doesn't go into that. 30, 6 goes into that. So I would rather do that than multiply 15 times 6. I want the smallest numbers I can as I'm working. It makes it less likely to make mistakes, and you don't have to reduce as much at the end. So 15 times 2 is going to get me 30. So 1 times 2 is 2. And 6 times 5 is going to get me 30. So I'm going to add 2 and 5, and I get 7/30. So my answer there would be 7/30. For number 4, 7/16 and 1/4. And we are subtracting. Remember, number 1, are the denominators the same? No. Number 2, does 1 go into another one? Yes, 4 goes into 16. So I only have to change one fraction, the bottom one. 4 times 4 is 16. Remember, whatever I do to the bottom, I do to the top when I rename. And I am subtracting. 7 minus 4 is 3. And the 16 just comes right over. So 3/16. For number 5, 7/8 minus 3/6. Use your strategy. Are the denominators the same? No. Does one go into another? No. So I have to go to the renaming. And instead of multiplying 8 times 6 and getting 48, which is a big number, I'm going to start skip counting by 8s. So I have 8. 6 doesn't go into that. 16, 6 doesn't go into that. 24, 6 goes into that. And you can use your times table chart to help you with this. You look at the column that has the 8s and the column that has the 6s, and you look for a common multiple, the least common multiple. So let's rename these. 7/8 becomes 21/24. 3/6 becomes, 12/24. When I subtract 21 minus 12, wait a minute, what did I do there? 8 times 3 is 24. 7 times 3 is 21. 6 times 4 is 24. 3 times 4 is 12. Oh, I know what I did. So I'm going to wind up with 21 minus 12 is 9. That can actually be written in lower terms. Neither of those are prime numbers, so I can reduce this. And you might have missed this last year in 4th grade. So the book has us divide by 2. That's not going to help us because 9 is not divisible by 2. But remember, we are going to look for a common factor of 9 and 24. So I am going to think of my factors for 9, 1 times 9 and 3 times 3. Think of my factors for 24, 1 times 24, 2 times 12, 3 times 8. There we go. I've got a 3 right there. So I'm going to take that 9/24 and divide it by 1, but I'm going to show my 1 as 3 over 3. 9 divided by 3 is 3. 24 divided by 3 is 8. Lowest term answer is 3/8. 9/24, if you're in middle school, they might give you partial credit for that, and they'll tell you to reduce it. Let me get this up here. Oops. Wrong one. Okay, I need a little bit more space for number 6. So I have 7/8 plus 4/8 minus 2/4. So I do what's in the parentheses first, so it's 2 problems here. Go through my strategies. 1, are the denominators the same? No. 2, does one denominator go into the other? Yes. So I only have to change one fraction. And 2/4 becomes 4/8. So when I subtract 4/8 minus 4/8, I get 0. So for this one, 7/8 plus 0 equals 7/8. Let me scoot down a little bit. And you're going to see the problems are, the first 4 problems are set up nicely. The next ones, you're probably going to need paper and pencil. And when you get to the bottom, you solve the problems in the parentheses first, and then you either add or subtract or whatever you need to do the third value. So I would suggest, like number 11, I would be writing this in my notebook. Do I have enough room off to the side? Number 1, denominators aren't different. Number 2, 3 goes into 15, so I can leave that guy alone. And this one, I'm just going to make a 5, so 17 minus 5 is 12/15. So I would definitely be using a notebook to help you out with this. You can't jam all this in here. There you go.